I am working on the state machine and thermostatic functions for the smart thermostat project that is ongoing. And I ran across an interesting inquiry, had been in the back of my mind for a bit, which was when a thermostat is set to operate in the heating or the cooling mode. So this is an inexpensive Honeywell thermostat that has a switch at the bottom that says heat, off, cool, as you can see, but right now it's in the heating mode because it's actually pretty cool out today. And if I were to go and set this to a warmer temperature, you'll hear the relay click. There it goes. Heat comes on, but it's one relay, and I don't think it's a particularly complicated relay configuration. What is actually being done on the switching side on the 4-wire configuration thermostat? That is, when heat is commanded on, or let's do this, turn it back to satisfying the heat condition. Heat turns off, and I say, nah, I want to cool instead, and let's make it really cool. Let's listen to it turn on the relay. It may actually, oh, sorry, it needs to be below 73. Cool comes on. Okay, cool. It sounds like it's a single pole, single throw relay. So like it's closing across the 24 volt line coming in, and then one of the taps for either heat or cool. And it's excluding the fan, which is my hypothesis is that basically only one wire, heat or cool, is being set. And then if you want the fan on, this is actually a switch that is just turning, it just switches across 24 volts to fan to turn the fan on and off, or turn the fan from on to auto. So I kind of wanted to verify that prior to finishing the state machine. What I thought is I'd get out my trusty voltmeter and hook it all up, and we would just go and quickly probe these to see what's happening when I switch between the various modes on the thermostat. So in order to do this, I'm going to put this in resistance mode. One thing is the various wire names, which I always get wrong, and I'm going to have to write down here because I get them screwed up all the time whenever I have to wire up a thermostat. So there are 4 wires. Basically it's the, oh man, I am so bad at remembering these. I'm going to have to actually get up and go look at the wall real quick. R, C, W, Y, and G. There's no like 24 volts in common. Each one of the returns is a common to actually send 24 volts down a particular line to tell the furnace controller, hey, I want heat, hey, I want fan, hey, I want cooling. That's all it's doing. But we need to remember what each of these things actually means in a 4-wire system, which I'm going to go look up real quick. So G is for fan. This is how awesome these actually are. G is for fan. Y is for call for air conditioner. And W is for heat. And then R is 24 volts. AC, this is coming from a low voltage transformer. I should probably also add that this is a transformer located inside the furnace, which is about they're usually about a 40 VA safety isolating transformer, which is why you can have thin little wire running up to the wall not running through conduit or as Romex shielded or armored BX cable. It just kind of comes up through the wall, pokes through sheetrock or whatever to get to the thermostat. So now we know what we've got. And so what I'm curious to see is that on the taps here, so here on the back of this thermostat, there is I can see, it's probably not going to come out too clearly on the video, but there is silkscreen tracings for W, for Y. I'm pretty sure this is actually, because it's a less expensive one, they didn't actually bother with all the things besides the typical 4-wire system. So I see a G, a Y, a W, and a C. So a G, a Y, a W, and I know that RC, it's not marked here, but this is RC. These two here are 24 volts. Get some alligator clips. So red is red. And on the actual wire on my thermostat on the wall is actually the last peg. We'll use white for heat, which is W. Green is for fan. G is for fan. And we're going to do blue instead of yellow. First thing we're going to check is the fan, which is going to be interesting. So if I just flip the switch, I'm thinking that as soon as I flip it, there's no sound unless it's using like a... Honestly, I think it's just a switch, because if you were to do something solid state for AC, you would need a triac, you'd need more electronics than just a simple little like a switch like this that just can handle 48 volts. So green is fan. So right now the fan is off, overload, high impedance. My expectation is as soon as I flip this switch, it'll immediately go, yep, immediately, as soon as I flipped it. So my thinking is that that switch directly flips the fan on and off. There's nothing internal that's doing that. The next question is, when it commands heat or when it commands cool, does it just turn on heat and cool? Or is it turning on is it connecting this and the fan, or in the case of air conditioning, the air conditioning and the fan? My thought is it's just the one and the other, that's it. And then the furnace controller knows like, hey, you called cool, I need to turn on the fan too, otherwise I'm gonna freeze over the evaporator. And in the case of heat, you'll just go into, you know, an over temperature situation. Let me flip this around with all these alligator clips in the back of it. So we're going into heat mode. Turn this up to about 75. And it'll click on. This will definitely go down to 0. It did not. Why did it not? Do I have the wrong things clipped off? Fan auto. W is heat. Oh. Oh. We got an error. I don't know what that means. I think I just pissed it off. Take the batteries out. What does 5 mean on Honeywell thermostat? Let's investigate that. 5. 5, 5. I don't know if you can see that on the screen. I definitely pissed it off by doing something. All right, so there's no readily available answer, so I'm just gonna, it's back to the thermostat screen. Let's just try that again. R and W. R and W. Set 44. That's weird. That's weird. No. Why? What terminal is it actually? There we go. Oh, it's jumpered. Duh. Okay. There we go. It's jumpered, but it's the same. It's only switching on that pin. It's jumpered at the wall, so it doesn't switch on this pin. It only switches on this pin that the red alligator clip is now connected to. Exactly what we expected. The $50,000 question. If I remove the white, because the heat is on, if I connect the fan, is it also on? It is not. So it is just turned on heat and nothing else. Cool. Switching off heat. We're going to switch this now down to, oh, I can't switch to anything. Let's turn the heat, cool off for a moment. cooling is off. First thing is we're going to check the blue for cool and see when we select that on that it actually turns on the cooling. So we're switching it all the way down. That should definitely turn on, and then this should go to 0 ohms impedance. It cannot cycle right now because of a delay is to prevent short cycling of the compressor on the air conditioner. Most air conditioners that exist now, because they have maybe 20 to 25 year lifespan, even the modern-ish ones, it's good to wait 3 to 5 minutes. And what short cycling is basically the air conditioning turns on, runs for a short period of time, turns back off again, and then either you walk up to the thermostat and go, oh my, I'm still hot, and turn it all the way back down again, and then it turns back on again right away, right after it had turned off. Or there's an issue with the location of the thermostat. Maybe it's near a sunny spot in your house, it's near a window, it's near something where there's a lot of temperature fluctuation, and after it is cooled, the temperature rapidly rises back up again to the point where this actually goes to try to start the air conditioner again with too short of a time between the previous time the air conditioner shut off. Well, this is not working. So either the clip fell off or I have it on the wrong thing again. Y is for cool. We have red. Oh. So it closes across different terminals. Interesting. It closes across different terminals when it's cooling versus when it's heating. Now they're jumpered together at the wall, so it doesn't matter at the wall. I can just put one wire in and it's fine. But it jumpers different pins. The reason why they have it and it's jumpered together is just in case you have other methods of heating your home that this is attached to that are not forced air from a natural gas source, and you only have a blower unit and a evaporator and an outdoor unit for cooling, so that when you turn that on for cooling, it uses one pin across another pin for the cooling function. And then if you have, let's say, baseboard heating, electric or a heat pump, and so they just default to that because it's probably the same design structure for this unit all the way up to probably their $100 or more units, just with Wi-Fi and other things attached. That's why it's jumpered off at the wall and they don't even worry about it in a thermostat. $50,000 question. Remove this and connect the fan. The fan is on as well, which makes sense because when you turn on your heat, if you ever were to stand next to your furnace, on any furnace, the blower motor does not just turn on when the furnace turns on. The furnace controller, which is inside the furnace, there are controls that have been specifically evaluated for use as a safety control. There's a lot going on that's protecting the furnace. The next one that's coming up, the notion of hysteresis. I'll see you in the next one.